So, let's just make a bubble sort.
He started like last week. He's almost done. He's He is.
You're done?
Almost. How far are you into it? I set up my Git repository last night, so I'm almost done.
Yay. All right, let's bubble sort some data. So we'll have an outer pass that's just going to go 10 times. You can go as many times as you want, as long as it's at least the number of elements minus 1. Our inner pass, we're going to go from 0 through 8, okay, because we're comparing element I to I plus 1. I only want to go up to the next to the last element. And I'll compare data I with data I plus 1. If they're in the wrong order, so I'm going in increasing order here. So if data I is bigger than I plus 1, we want to swap them. So let's save one of them in a temporary, and then replace that temporary with the thing after it, and then replace the thing after it with the temporary we saved. So that's the guts of a bubble sort on integers, right? And then we can just print it out in a for loop. And I think that should work, unless I messed up the initialization, because I don't know how to initialize arrays. Yeah, so for strings, we're going to want to use string copy. And then you can use just equals for swapping the counts, because you need to keep them both sorted. All right, so there's an increasing order. Does that make sense?
Yes.
Okay. All right, so other questions on PA4?
Make files.
Make files. Good, good, good. Well, let's pick on my other. All right, let's just pick on this. So let me show you the easiest makefile in the world. So your makefile is just named makefile. Doesn't have an extension. Uppercase M I prefer, but you can also get away with a lowercase one. But call it an uppercase M makefile. And it's just a text file. It just contains human readable information that this program called make is also going to read. Okay, so I have my sample program. It's called go3.c, and it makes an executable called go3. And that's all I have. Everything's sitting in one file, and I just want to make a make file for that. Let me show you the bare minimum. This will work as a make file, but it's not a really ideal make file. So here's my main program. Right? That's a perfectly fine make file. So to build my target, which I'm calling go3, I need to have go3.c, and if I do, there's my GCC command to build go3. GCC-o go3 go3.c. And with that in my directory, if I say make, it'll tell me go3 is up to date. If I remove go3 and I say make, it'll execute my GCC command and make my file for me. And if I say make again, it tells me it's up to date. If I edit go3.c and I say make, it'll recompile it. And then if I say make again, it'll say it's already up to date. So a 2-line make file will work as a make file.
So, quick question. So make, is that a pre-built function?
Make is a GNU make utility,
Okay.
right? And it's sitting under probably /bin /user bin. It's a program written in C. And when you say make, it looks for a file in your current directory named makefile, and if it finds it, it opens it up and it processes the commands. So you can do this, and it will get you points for your makefile part of PA4, right? Which is, I don't want to have to figure out which programs need to be compiled to make an executable, so you give me a makefile and I'm just going to say make, and it should do whatever has to happen. And this will work. And if your program is in a single file, this is pretty much as good as a makefile will get. Okay, makefiles really make more sense when you have multiple files. And if you have 5 files, right, you could do the same thing. You could say go3 depends on go3.c and this .c and that .c, and then just have a big long GCC. And that'll still work, okay, and that gets you your points. But at that point, you really have the option of making a makefile that does its more tactical compilation. That actually says, oh, you've only changed one of your 5 files, I only need to recompile that one file. And so you make a fancier makefile. And we can talk about that another day, but I'm guessing most people are probably satisfied with this level of makefile for now.
Does makefile have to be capitalized?
I would recommend capitalizing. It'll work with uppercase or lowercase.
Okay.
But if something goes wrong and I have to look at your makefile, I'll look for an uppercase, and if I don't, then I'll get a bit of a frowny face and work with the lowercase one. It takes either. All right, so at least do that, but use your file names. All right, other questions? So I posted another piece of code onto the shared code area from Canvas. It's called Sample Phrase Builder. And I also posted something called Sentences. And this is a small variation on code we were playing with last week. This was the example of a getPhrase function. That's not the full getPhrase function that we really want. It's a sample of it. So your main program the way I've been describing this, your main program really does 2 things. It says read a phrase from our input, and then save that phrase. And then read a phrase and save a phrase, and so on and so forth. And that's really what PA4 does for most of the time it runs. Reads a phrase, saves it, reads a phrase, saves it. And it keeps doing this until you hit the end of the input, end of file. And then you sort your collection of phrases that you've saved, and you print your collection of phrases. So your main is really 4 things, 2 of them in a loop. Read and save, read and save, read and save. And then when you're done reading, sort your collection of phrases and print them out. So I've had people asking me, so I've got super duper get card done. How does that go with the phrase business? How do I go from reading a character to saving a phrase? So read a phrase, right? My suggestion is, first of all, make this its own function, make this a function, make those functions. Okay, why? Because logically, these are separate tasks, right? Reading a phrase has nothing to do with saving a phrase. Reading a phrase is all about, let's get a character, let's make it uppercase, let's change new lines to spaces, let's ignore quotation marks, let's see if this is the start of a phrase. If it is, let's read some more characters until we get to the end of a phrase. Here's the end of a phrase, let's take everything we read, put it in an array, put an alternator on. There's our phrase, right? That's what this thing does. Has nothing to do with saving it in a dictionary, sorting it, printing it, finding number of times, nothing like that. Logically, it's kind of its own function, right? You could use this in a number of different ways. In PA4, the way we use this is after we've got a phrase, we save it in a big array of phrases, a dictionary. And we save it in a way where if we've seen the phrase before, we don't store it a second time, we simply bump up an integer that says we've seen this phrase twice. Okay? That's logically its own function. Doesn't really matter where this phrase came from, if we typed it in, or if we read it from a file, or if we generated it randomly, or we got it from a network connection. How we read the phrase has nothing to do with how we save it and tally it. Right? So save and tally is kind of its own thing. And these happen in a loop, and then you've got a dictionary, sort and print are kind of 2 pretty independent pieces. Right? Print's just a for loop, sort is a bubble sort. All right, so how do we read a phrase? The main gist of this is this sample code that we did the other day. Use your super duper get car to read a character, copy it into an array, get another character, add that to the next spot in the array. Keep doing that until you get to the end of a phrase, and then put on an alternator and return. So ch equals super duper get car. Alright, that's mainly what reading a phrase is. Call your super duper get car, save the character that you got into your output array, right, until you reach end of the phrase, which is not necessarily EOF. It's a period, a comma, a semicolon, etc. And then after you do that, add your null terminator. And now out is your phrase. So this is this sample phrase builder code. I'm not using super duper get car, I'm just using get car, but you would use your super duper get car so we know things are uppercase and so on and so forth. And output is where I'm storing my phrase as I build it up. Output location is the location of the next thing I'm going to store in that array. ch is just a temporary integer. Get your first character, and here I'm saying if the character is not a period, a comma, or an exclamation mark, it's not the end of a phrase. So it's a simplified definition of where a phrase ends, but it's more than just a dollar sign we were using last week. So if it's not the end of a phrase, save it in your output array, bump up our count of how many things we've got saved, get the next character. And remember, every time you call getCar or SuperDuper getCar, it ingests another character from the input. Okay, and once it ingests a character, that character is gone unless you save it somewhere. So if I call getCar 5 times, I will ingest 5 characters from the input. If I want to ingest a character and do 5 things with it, save it in a variable, an integer, do 5 things with it. Okay, and don't call getCar until you're ready for the next input character. So here I read the next character, go back up, see if it's the end of a phrase. Yeah?
So you're using integers for the characters? Can
Mhm.
you use car?
You got to use an int,
Okay.
because getCar by definition returns an int because it can also return something that's not a character, which is EOF.
So don't cars store an integer value?
They store a very small integer value from 0 to 255, which is
Right.
the ASCII code of the character.
So, and getCar is returning the ASCII code, right?
Mm-hmm.
So why can't you store it in a car?
Because getCar can also return EOF, which is not an ASCII value,
Oh,
right? And to store EOF, which is -1, you need to have an int.
oh,
Otherwise, it's indistinguishable from ASCII code FF.
gotcha.
All right, so there's the main loop of our phrase reader. Keep reading until we get to an end of phrase, add an null terminator, and then we just return. And so in my main program, every time I call get phrase, temp should be populated with the next phrase from the input. So I can test this just by calling get phrase a bunch of times and printing out what it returns each time. And so I made a sample sentence file with the things I'm terminating phrases with. And so if I run my sample phrase builder with that file as input, right, my first phrase is hello, and then this is a test, and how are you? I am shouting, yes, I am, I am. And then a seg fault because I didn't bother checking for end of file. But that's basically chopping my input up into phrases, simplified phrases, where I'm only ending with these 3 punctuation marks. But you notice that most of my phrases start with a space, right here. And that's because I'm not doing this other thing that we want to do in our phrase reader, which is look for the beginning of a phrase before you start storing characters. And remember, a phrase begins with anything that's not a punctuation mark or a space. So in the very beginning here, we need to look for start of phrase. And that's a loop. And then here's our main loop. This is where we save phrase. And this is where we terminate the phrase. And SuperDuper getCar is this business of get a character, and if it's a parenthesis or a quotation mark, get another character, and then convert it to upper and see if it's a space. So main is calling read phrase, which is calling SuperDuper getCar, which is calling getCar. It's a hierarchy. If you've already gone pretty far down the road doing this a different way and you feel like you're most of the way there, keep going the way you're going. But it's probably easiest to have some sort of partitioning based on functions. as opposed to trying to call super duper get car inside your save phrase, because now you're trying to find the start of a phrase, build up a phrase, find the end of a phrase, and if you're trying to do that directly into your dictionary, for example, then you got to figure out, okay, was this phrase unique or not? And if it is, you need to somehow remove the second entry from the dictionary and so on. And I've seen some people also trying to sort while they're building the dictionary and reading phrases. And you can do all of these things, right? It's just how many things do you want to do at once, basically. To me, I like sort of making my life simpler, so do one thing at a time. That's why I keep talking about like partitioning and modularizing.
I know that you want the assignment in a repository called index with a capital I. Is there anything specific you want the program called?
No, you can call it whatever you want, and your make file is going to make the executable. So, yeah, I thought I had said lowercase index, but I couldn't find that in the assignment, so you can call it what you want. And so again, you can develop this as you go. You can test it, right, as you're developing it. So if you have super duper get car, you can test that inside a phrase builder, right, with get a phrase, print it out, get a phrase, print it out. Right, I can take this, I can run it on War and Peace, and I should get the first 10 phrases out of War and Peace. And if I'm just trying to terminate phrases with those 3 punctuation marks, right, this looks reasonable. Now everything should be uppercase, and I should be ignoring those dashes in the middle, and so on. But if I haven't done super duper get car yet, and I'm just using get car, I can look at this and I can say, yeah, it seems to be breaking things up at phrases. Chapter 1, this new line should have turned into a space, right? I see I have frightened you has a new line in the middle. Well, if my super duper get car changes new lines to spaces, this will say, I see I have frightened you. Sit down and tell me all the news, right? And it'll come out on one line. And these leading spaces won't appear. If I'm looking for the beginning of a phrase, the single quote won't appear, and so on. And then save phrase, you can develop that either if you have read a phrase working, you can start saving those into your dictionary, or you can just write your save phrase function and just feed it phrases, right? Make a main program like this that just says, you know, save phrase blah, save phrase blah, save phrase blah. Just call it with a bunch of different phrases, some of them unique, some of them appearing more than once, and then you've got a nice simple test case, and you don't have to worry, is there a bug in my read phrase? Am I not null terminating or something like that? You're just working on this save phrase, and you know what you're passing it, and so if it's going to blow up, right, you can step through it in GDB, or you can add some print statements or something and figure out where it's blowing up. And once you got these two, you're mostly done. Okay, so try to get the print function to work, because my first pass at your code is going to be to make it by saying make and then to execute it on a sample file. And if it generates output, right, I got something to grade. If you never got around to writing your print function because you left it for last and ran out of time, there's very little I can grade from the output. You might have 90% of the code working, but if it doesn't actually print out your dictionary, right, then I have to go in and grade your code based on how it looks, right, how I think it will work, and so on. So make sure you have a print function and that you call your print function somewhere to dump out your dictionary. But more generally, if you don't have your program done in the way you want it done by the time it's due, make a README and push that over into your repo. And if you've got test cases, right, if you wrote the read a phrase function and you wrote a main program to test it in a test file, tell me what those are in the program, right? If I have to know something to compile it, tell me how to compile it. And if you say, you know, my read phrase works great and my save phrase works great, but then when I tried to print it, I got a seg fault, so I took that out, right? Let me know where you are, what you did, what you tested, and so on, in a way that lets me do the same thing, so that I can say, you know, yes, your read phrase works, yes, your save phrase works, right? And get you as much credit as possible. So make a README, I'll look for that. Call READMEs uppercase so they stand out when you look at the files. That's just kind of what people do.
So for README, would we break it down by function and then kind of describe what it does?
Up to you.
Or-
If you make a file called README, that'll get my attention, right? If I feel like I need to know what's going on, I'll look for that, and you know, just talk to me in there.
Okay. Like, hey Nick,
Hey, yeah.
that'll be the entire README.
Yeah, that won't help a whole lot. But you know, like I say, you know, my save phrase is working, but I never got read a phrase to work. But here's the test file I used. You know, here's the test program I used to work with save phrase. And you know, there's a main program that saves 10 phrases and prints them out, and then I can run that and say, yeah, okay, you're saving the dictionary, fine, you get points for that. And read phrase, you know, worked great until I did this thing, so I got rid of this thing, right? But I left it commented out in the code, and then I can look at the code and I can go from there. So, you know, it's not being graded by a machine, so take advantage of that, basically. So other questions? So if you want to save your phrase, right, you need to have the dictionary you're saving into. You need to have the count array that tells how many times each phrase occurred. You need to have the length of the dictionary, and you need to have the phrase that you're storing. And remember, arrays don't have an inherent length. I'm declaring my dictionary to hold 1,000 strings. I'm declaring my count array to hold 1,000 integers. But at any given time, if I just say save phrase and I just pass it my dictionary and my count, I don't know how many things I actually have saved in that dictionary. I know it can hold 1,000 because I wrote the code and I said 1,000. But does the dictionary contain 5 phrases or 2 phrases or no phrases or 1,000 phrases? There's no way to know just from looking at the dictionary. So you got to pass in something that says how many things are stored in the dictionary. That's what this dictionary length is. And then to actually save your phrase, you do one of two things. For I equals 0 to dictionary length minus 1, if dictionary bracket I matches phrase, then our phrase is in the dictionary. It's in there at position I. And so increment the count corresponding to that phrase and return. So if our phrase already appears in our dictionary, somewhere in this for loop we will encounter that, and we'll bump up the count by 1, and we're done saving our phrase. Otherwise, this is a new phrase. So save your new phrase at dictionary bracket dictionary length. So copy your phrase into there. Set your count of that phrase to 1, because we've seen it once. Increment your dictionary length, and you're done. So this comparison, this is string compare. Alright, so if string compare two strings equals 0, then the phrases are the same. Otherwise, they're not. And this down here is string copy. And if you change the dictionary length, you got to somehow pass this back to main. Right, because this is a save phrase function that gets called from main. So dictionary length might be a variable I declare inside main. When I call save phrase, that gets passed to save phrase, but it could get incremented. So there's a few ways you can do that. I could pass dictionary length by reference, make it an integer star. It's a little bit of a pain because here it's star dictionary length, but you can do that. I could return dictionary length as the value of this function, and in my main program I could say dictionary length equals save phrase, all of this stuff. Right? You can make dictionary length global, but I'd rather you didn't. Or you could have save phrase return a flag which tells me did I find a new phrase, and then in my main program I could say if save phrase equals 1, then increment dictionary length. In other words, do this in the main program instead of inside here. Up to you. There's different ways to do it, but the important thing is if I find that this is a new phrase and I save it in my dictionary, this value that I passed has got to get incremented in the thing that called me, okay, the main program. And just doing this doesn't change it in main, because C always passes by value. But that'll be really obvious because you'll go through your whole program and in the end it'll say your dictionary is empty, and that'll be a hint. Yeah.
Is there a reason why you preferred to not have dictionary length be global?
Global, because globals are kind of sloppy. There's almost always a better way to do something than with a global, and some teachers get really upset with globals. They like take off points per global.
Oh.
Yeah.
In general, like
Yeah.
if there is a global.
Yeah.
Okay.
Because they're almost never necessary. There's usually a way to do it by passing it to a function, and it's you know, it's like a go-to. One go-to is not going to destroy the world.
Yeah.
Usually, but if everybody uses go-tos, you end up with a big mess, which is where computer science went in the 70s and 80s, right? So one global in your program is not going to make your program, you know, insecure and buggy and impossible to maintain and so on. But the more you can avoid it, the better. And there's always a way around it with pretty much everything we do.
Is it okay if we happen to already have a global?
Yeah, that was the question dancing around the edges. I'm not going to take off points if you make dictionary length global, but I might put a comment in there saying like, you know, think about how you could do this without a global. But no, I won't take off points for it.
What if we have dictionary itself as a global?
Well, if you're going to do dictionary length, you may as well do dictionary as a global too. So
That's what I did.
yeah, that's okay. But like I say, be aware that other teachers at other schools will sometimes, like, you know, if you use a global, you get an F, that kind of thing. So something to work towards. All right, other questions?
When you initialize a pointer to something, and you have to, like, do you have to set it to null, or can you just initialize it? And what does it get set to?
You can just declare it like char star temp semicolon. That's fine. It's probably initialized to a 0, but don't count on it.
Fair enough. So it's safe to always initialize it to null.
Yeah, but if you're going to assign it to something, like if you're going to do this, right, if you're going to do something like that, right, or temp equals quote hello, right, then you don't need to set this equal to something because you're about to change the value of it anyway. So that's perfectly fine.
For this,
Oh, you had a question?
Oh, yeah, so the index sample, are we supposed to essentially just trying to be copying that output, like whatever it outputs be?
Yeah, and don't get too worried about the details of War and Peace output. Okay, because you might be, one of us might be off plus or minus one, or the really long phrases might look slightly different at the end, and so on. But yeah, the first sample program in the assignment should give you that output. An index sample should mimic that.
so for this assignment, would it generally just be good to use like character arrays for the strings instead of using pointers?
Yeah.
Okay.
The way I've suggested it, everything should be car bracket 201 or car bracket 1000 bracket 201.
Gotcha.
My brain is on Panda Express right now. Yeah.
It was really good.
Yeah, I'm sure.
What do you get when you go there?
I'm vegetarian, unfortunately.
Oh.
So, but I love their orange chicken.
Oh. That's quite a predicament you're in.
Yeah, because I love meat. But all right, other questions? Yeah.
So for printing all this out, I'm kind of curious, when you're printing out the whole thing, you have the phrase and then the amount of occurrences in brackets with like 6 zeros. How do you have those? How do you put in those zeros? What can I for that?
%.5D.
Yeah. Percent 05D. Yeah.
Okay.
Yeah. So count comes first, and then phrase inside brackets. So if you print out with %05D, it's an integer, occupy 5 spots, and pad the beginning with zeros. So that's easy to do. And then if you run it through sort, it'll sort by number of occurrences without doing a dash n.
How available will you be tonight for?
Oh, I'm going to sleep as soon as I get home.
Okay. That's really good.
I may hop online later on, but it was a long day yesterday, so I'm probably going to be offline for the bulk of it. But yeah, you can always try shooting an email.
Cool.
If you try to reach me in Discord, make sure you send me a direct message, because I don't really keep up with Discord. I pop in there once in a while, but mostly I'm just leaving that for students. So if the chains get really long, I don't really go back and read all of it. So yeah, do what you can. Like I say, at least try to put a print function that gets called at the end, so that when you run your code, it produces some output, however far you got. If you're not converting to uppercase and ignoring special characters, and if you're not counting phrases and you're just recording each phrase individually, and you're not sorting the final output right, that's still worth a bunch of points. Okay, it's worth a whole lot more than if I don't have access to your repository, because that's bad. Or if I have C code that I can't compile, right? That's a hard one to get a lot of points on. So, your best version should be what you're kind of constantly pushing over to GitLab, so that when I download tomorrow, I've got, something good to grade.
In GitLab, it's just you. It's not that one with the 3, right?
Yeah, I think I deleted that one yesterday because
Okay.
some people were pushing to that.
Okay.
But yeah, it's just Nick Macias, 10 letters, with some weird picture of me. All right, good to go. So separate question, how many people here, show of hands, have a laptop that is running some version of Linux, including a Mac or a Windows machine with Cygwin, or a laptop with Linux, or something with VirtualBox with Linux? Let me see, number of hands. Maybe, okay, that will probably work. Okay, thanks. So PA5 is going to be a project that is hard to do on the Linux server. It's going to have a graphical component. It's going to be a graphical menu-based system. And you need one of those environments to work it on, preferably a Windows machine, preferably a Linux machine, or a Windows machine running Cygwin, or VirtualBox, and possibly a Mac.
Linux is free. Just wipe your OS and get Linux.
There you go. Yeah. Okay, cool. So yeah, and PA5 is also a group project, so we'll have groups of 3 or 4 people. So if you don't have such a machine, right, you just want to make sure you're working with someone who does. But we'll talk about PA5 tomorrow.
I just shrunk my main partitioned like 100 gigabytes or something, and
Mhm.
installed Linux on that.
Yeah.
Small one.
Yeah, and Linux doesn't need a lot of space. So if you don't mind dual booting, you can squeeze it into a little bit of your hard drive. Or download Cygwin or VirtualBox.
Wait, what was it?
Cygwin,
CY.
Cygwin.
What's the graphical component for it?
Zenity.
What's that?
Zenity is a way we can make windows and menus and buttons and stuff like that from Bash.
Okay.
Wow.
Yeah,
No freaking
way. So we'll talk about that tomorrow.
Oh.
So do we need Linux or do we need Bash? Like, is that why you're asking for Cygwin or?
You probably need Linux. I don't know if you can do it from the Bash thing that comes in Windows. You basically need an X Windows server, which you get with Linux and you get with Cygwin.
Subsystem in Windows.
Yeah.
Or Linux subsystems.
And you can run the Linux native on Chromebooks now. I just found that out a few weeks ago. And it seems to work pretty well. All right, we got 7 minutes. Let's talk more regular expressions. How far did we get with regular expressions yesterday?
Nowhere.
Oh,
You said you're
so nowhere. Okay, so regex. So we know that if we're sitting inside VI and we want to search for something, like we want to search for the letter I, we can say slash and I, or we can say slash IN, and it'll move our cursor to where it finds an I followed by an N in our file. And if I hit the letter N, it'll search for the next occurrence of that. And if I hit the letter N, it'll search for the next occurrence, or it will wrap back around to the top and tell me that it wrapped around. And we can do these things like colon, substitute, slash, some pattern with some new pattern. And that'll replace the occurrence of IN with, in this case, 5 H's.
Imagine having that name.
Yeah. So I can say colon, substitute slash old slash new. And we can do this in VI, right? That's what the colon does, it brings us down to this special part of VI. But we're going to learn about a program called sed that will let us type things like this and do them on a file without having to go into VI. And if I want to do this on multiple lines, I could say something like colon 1 comma 5, substitute IN with 5 H's, and now we'll do it on every line in the file between lines 1 and 5. So I can say colon 1 comma 5, or I can say colon 1 comma $, and $ means the last line of the file. First line is always just 1, so we don't need to know what that is. But if we want to do it everywhere in a file, we could do that. So now I could substitute 1 to $, substitute all of my E's with X's, right?
What's your name?
And you notice it got the E in Barney, but not the E in Rubble, or the E at the end of Flintstone, or the 2 E's in Jetson, because these substitutions only happen once per line. But at the very end, I can say /G, and this means do everywhere, or do multiple times.
And isn't /I case insensitive?
I think so. So do multiple times per line. So I can say :1, $, substitute E with some uppercase X's globally, and now every occurrence of E on every line in my file gets replaced with this pattern of some replacement pattern.
Can you do something that makes it so that every letter gets replaced by that pattern?
Yeah. So
Isn't that like ass?
so we can wildcard. So a period matches any character. So if I say $1, substitute period with a bunch of X's globally, right, that's what my file turns into.
What if you put the period at the end?
What do you mean at the end?
Well, put the period as... Oh, because it would just replace it as periods. Yeah,
Yeah.
that's lame.
But not as lame as you would think.
Oh, okay.
We'll be able to do good stuff with that.
Cool.
So let me show you where this is going, okay? And tomorrow we'll be mostly talking about PA4 and PA5 and Zenity, so we may not get back to this until next week. So let me just show you where this is going. We can do things like, for example, match the first character of a line followed by a succession of characters followed by a space, and replace that with just the first character of the line. So if I wanted to change this into first initial space last name, I can do something like this.
That's not human readable.
Right? And that'll do that. Or if I wanted to change it from first name to last name, comma, space, first name, I can do something like this. Okay, so these things I'm typing down there, these are called regular expressions. And they're really hard to read, but they're pretty easy to write once you know a few things. And we're going to learn probably fewer than 10 things that build up into regular expressions. But with that small set of things, we're going to be able to do things like that, right? Ways to sort of pre-process and rearrange text files. I don't know how many times a week I do this. It's a lot, right? I've had jobs where I spent a good part of my day just doing this kind of thing. Not because that was my job, but because it's really useful. If you're processing a lot of data, data comes in lots of different forms. When I want to make an attendance sheet, I go to Canvas and I export from the grade book, and there's no grades, but I just take the first column from a CSV file, and it's first name space last name, right? And I want to change it in, or it's like last name comma first name, and I want to change it into this, and then I want to alphabetize by last name, right? I can do all that with regular expressions. So we'll play with this possibly tomorrow, but most likely next week.
With the group project, do you want us to use Git and like pull requests and stuff?
I'm going to let you do what you want with managing the code for PA5. All right, so keep rocking on with PA4, and I will see you tomorrow. Yeah.